Okay, just imagine this for a second. You're up in the air, and then you hear it, that gut-wrenching sputter from the engine. It's a sound that makes everything go quiet, whether you're a pilot or just someone who's ever had their car act up. So today, we're going to unpack what happens next inside one of the most popular planes in the world, the Cessna 172S. It's one of the very first things pilots learn. That terrifying sound might not be some huge catastrophic failure. Nope, it could be something surprisingly simple to fix. In fact, just doing this one thing, switching the fuel tanks, is often the right and immediate solution. And that really is the big question, isn't it? How can one simple mechanical switch be the thing that keeps you from having a really, really bad day? Well, to get that, we need to look at the beautifully simple system that's working behind the scenes. All right, so let's put ourselves right in that cockpit. The engine sputters. What is the pilot's first move? And more importantly, why is it so incredibly effective? So the pilot reaches down, right there between the seats for this red handle, and it's a very deliberate move. You turn the arrow to point straight at both, and you feel for that solid click. That's the detent, the little notch that locks it in. That click confirms that fuel can now flow from both the left and the right wing tanks at the same time. It's a physical check to make sure the engine isn't being starved of fuel because one tank might be running low. Okay, so that little switch fixes the problem right then and there. But what's really going on behind the scenes? To appreciate the pure genius of this system's design, let's follow a single drop of fuel on its journey, all the way from the wing tank to the engine. Our journey begins right here, inside the two fuel tanks mounted in the wings of a Cessna 172S. If you fill them up all the way, they hold a grand total of 56 gallons of fuel. But here's where it gets really interesting. Of those 56 gallons, only 53 of them are actually usable by the engine. So why? Why are those last 3 gallons intentionally kept out of reach? Well, that so-called unusable fuel is actually a brilliant, totally passive safety feature. See, any junk like dirt, sediment, even water is heavier than fuel, so it naturally settles at the very bottom of the tank. The fuel lines, they're placed just above that level, making sure they only suck up clean fuel and leave all that gunk behind. Simple, right? So our little fuel drop continues its journey. After it leaves the tank, it passes through another critical checkpoint, the gascolator. You can think of it like a final trap, placed at the absolute lowest point in the system, designed to catch any last bit of sediment or water that might have snuck through. Now, because the Cessna 172 is a high-wing aircraft, gravity does most of the heavy lifting here, just pulling fuel down towards the engine. But it does have some help. There's a main pump that's driven by the engine, and then there's a secondary electric boost pump. That electric one is used to get the engine started, and more importantly, it's there as a backup if the main pump ever decides to quit. This thing is basically the brain of the whole operation. The servo regulator is constantly measuring the air pressure coming into the engine and comparing it to the fuel pressure, and based on that, it meters out the perfect amount of fuel to mix with the air for a nice, efficient combustion. And here we are, our fuel drop's final stop before it goes boom. The fuel distributor. It's got this cool nickname, the Spider, and you can kind of see why. It takes that perfectly measured fuel from the servo and splits it up perfectly among all the engine's cylinders. This makes sure every cylinder gets its fair share for smooth, reliable power. So we've seen all the individual parts of the journey. Now let's kind of zoom out and see how this all fits together into one big philosophy: safety through simplicity and having a backup for your backup. And this right here, this is a fantastic illustration of a core safety principle. Federal regulations actually require a gravity-fed system, like in a high-wing Cessna, to be able to provide 150% of the fuel needed for takeoff. That's a way bigger safety margin than the 125% required for pump systems and low-wing planes. It's basically using gravity itself as an extra layer of reliability. So the really crucial point here is that it's not just one thing. It's a whole series of simple overlapping features. You've got the unusable fuel catching the gunk, the power of gravity, the backup electric pump, all those filters, and of course, that simple both selector. They all work together to create a system that's just incredibly tough and reliable. So our single drop of fuel has finally completed its journey. What's the big idea we should take away from following its path? The main takeaway is that the Cessna's fuel system isn't complicated. It's the exact opposite. It's a masterclass in elegant simplicity. It just goes to show you that when the stakes are high, the most reliable systems are often the ones with the fewest moving parts and the most common sense backups built right in. And that leaves us with a final thought, doesn't it? From the 3-point seatbelt in your car to the circuit breaker in your house, what other brilliantly simple safety designs, born from these same ideas of simplicity and redundancy, are just hiding in plain sight all around us?